And now we will turn our attention to the pattern blocks. What I want to show you here is that we can define our whole to show both of the denominators, what 1/4 looks like and what 1/5 looks like. And so using the same reasoning as the set model, we want to think about how can we take one of our denominators, in this case fifths, and divide it into 4 pieces, or the other denominator fourths and divide it into 5 pieces. So that's how we can figure out how to define our fractions, our unit fractions, so then we can create a whole. So if we notice two rhombi are the same, and I'm just going to use 2 green triangles to show that 4 green triangles fit in 2 rhombi, or one rhombus is the same as 1 rhombus is the same as 2 one rhombus is the same as 2 green triangles. So therefore our fifth can be divided into 4 triangles. Likewise, our fourth, right, is 1 trapezoid, which is the same as 3 triangles, and then 2 triangles, 5 triangles total, or a trapezoid and a rhombus. And so what we can see now is, this is going to be not very accurate because I'm going to hand draw this, but we can see this shape as the trapezoid, and then which is half of that, half of the hexagon, and then a third of the hexagon is the rhombus. That's 1, 2, a trapezoid and a rhombus. Here would be another, so this is 1, 2, another trapezoid, and then again we can picture, and maybe picturing it is tough, we can actually put it on top. Trapezoid and a rhombus. Do this trapezoid, and a rhombus. So we can see, and then what we have left is a trapezoid, and then now these 2 little triangles, which is the same area as this rhombus. So we see this shape is 1/4. Here's the second fourth. Oops, sorry. We can see this one right here as our third fourth. And then now we have this space left over here. Maybe I'll change my color to green. I'm going to circle this in green, right? The areas we're looking at in pattern blocks. So we have the rhombus, or sorry, the trapezoid, the red trapezoid, and then the 2 little triangles, which is the same area. That's our 4/4. So that we could see the whole and how these 2 shapes make up the fourth and the fifth in this whole, right? We want to think about this idea of common denominators. We know in the set model we can create an array, a 4x5 array, so then we'll have 20 counters. So we can use that same reasoning of, well, our common denominator is going to be 20, and if we want to define that as our green triangles 1/20th, then we can see that we'll have 20 green triangles in this shape. I erased all of the markings here in my whole, and I'm going to delete these pieces. And then what I want, no, that one doesn't get deleted. What I want to show you is that we want to show both addends when in all of our models, any of our models. So we can take our 1/4 and make 5 of them to make 5/4. If you're still wondering how this is the same, I'm going to copy these and rearrange them so that way we can see so I gotta ungroup. We can see this hole. So we know, again, two trapezoids are the same as a hexagon, take up the same space. I'm going to make this look like that one there. So here we are, hexagon here, hexagon here, hexagon here, hexagon here, and now we have our extra rhombus there. But remember, this is not a hole, this is 5/4. So what we see is we have a hole. Let's see. With our 4 red trapezoids and then our 3 blue rhombi. Oops, sorry, this won't. And then our extra 1/4 piece here. So here again, our 3 hexagons and our blue rhombi, 1, 2, 3 hexagons, blue rhombi, and then our extra 1/4 piece. So here's our 5/4. We can then scroll down so that way you can see our just a screen. Our 1/5 here, we just do 2 of them to make 2/5. So here we have 5/4, and now we'll take our 2/5 and we'll put them all together. And now we can figure out our sum. So we see we have one whole and some more. What is this extra? We can think about it in terms of 20ths by counting each of these green pieces that take up the same space. 2, 4, 6, 8, 10, plus 3, 13 20ths. Or we can think about it in terms of 4ths and 5ths, but as we just counted, 13 20ths is not going to be equivalent to either 4ths or 5ths. So adding the labels on here, again, I just put all of the pieces together. Here, this is the same as 33 20ths, right? We see our whole, we can replace some of the equivalent areas, right? The blue with the green. We see we have traded out 2 blues, 2 greens for 1 blue, 2 blues for 4 greens, and think about this as 5/4 plus 2/5 is the same as 33 20ths, or 1 and 13 20ths, as we saw here. Right, the one whole, and then we counted these 13 20ths.